Hello everyone. Today our topic is gonna be geometric series with sigma notation, and my name is Zijing Dai. To begin with this topic, we have to first know what is geometric series. So geometric series is basically a set of numbers that has a pattern, such as this sequence. 1 times -3 is -3. -3 times -3 is 9. So we know that their common ratio is -3. All the geometric series has a common ratio. And for the first term, we called it A1. The second term, we called it A2. The third term, we called it A3, etc. This ... means all the other numbers has the same pattern, and this sequence is infinite. Second, we have to know what is the sigma notation. Sigma notation is basically the sum of a series of numbers, and this notation is written like this. With an n on top represents how many numbers is in this sequence, and an equation at the right written as this. ARK. R is the common ratio, and K is the how many R is there. There could be 0R, there could be 1R, there could be 2R. And A is the first number. So what do I mean by this? This can be written as this. So this means there are n numbers, and the k start from 0. So the first term is k at 0. The second term is 8 at 1. A at 1. K at 1 is the second term, which means ARN is one term more than n because it starts at 0, right? So I think this term, the last term, is gonna be n minus 1. So this is basically the sigma notation, and this is the geometric series. Now we know that what is sigma notation and geometric series. We can look at a problem of this. Calculate the sum of 10 terms. Start with k equals 0, and the numbers are written as 3 times their common ratio -3 and k to the kth power. This common ratio is the same as this, so we are assuming a situation where there are 10 numbers, and we can start at k equals 0, and we start at 3. So only the common ratio is the same to this problem. So how do we calculate this problem? We first find what is AR0. So we can write this as actually AR0 is k equals 0, so anything that has a 0's power equals 1. So AR0 equals 3, and every time we times -3, so -9 and 27. This is basically this series look like, and the last term would be the 10th term, and the 10th term will be 3 times -3 to the 9th power. So this is the last term, 3 times -3 to the 9th power. This is the last term. And to calculate the sum of this sigma notation, this series of number, we actually have an equation. This is the equation called sum of geometric series, and it looks like that. Sum in numbers equals the first number minus the first number times the common ratio to how many number there is power, and 1 minus the common ratio. So the sum of this geometric series is the first number minus the first number times the common ratio to how many numbers is this? And 1 minus the common ratio, which is -3. So we get that the sum of this geometric sequence is 3 minus, first we need to know what is -3 to the 10th power, which is the 9 in the power of 5, which is 81 times 81 times 9, which gives us 729 times 81, which gives us 729 times 81 is 729 which gives us this number 59049, and the denominator is 1 minus -3 is 1 plus 3 is 4. So we get -59046 over 4, and we can simplify this number to get the sum of this sequence, which is, first we divide it by 2, which is -1 4. Okay, actually I am dividing by 2, so this answer will be -2. This is the answer. We can't further simplify this number because we can obviously see that this number is not divided by 2 since it's not an even number. So the final answer for this geometric sequence is gonna be this. This is the geometric series with sigma notation by Zijing Dai. Thank you so much.